And then I couldn't relate those material impacts in terms of scarcity to the construction industry until over the last decade we've seen shortages of sand. And sand's a material that we take to be fairly abundant. And these material shortages are causing all sorts of price instability and supply instability to the construction industry. And then we have the problem of carbon, and how do we deal with that? This is a desktop counter that about November every year when I do a lecture I take a snapshot to see where we are. And pretty much for the last few years we've been tracking towards 43 gigatons per year, year on year. And earlier in the year I had the opportunity to visit and attend the Global Forum on Building and Climate breakout session from COP, focused on the built environment. And you'll hear from BPIE next. But this is a carbon tracker that shows us the progress we've made towards net zero in 2015 and the Paris targets. And you see that really we've made no progress at all. So we need to accelerate and speed up that process. Earlier in the year, we produced a report with the World Business Council for Sustainable Development, looking at where the carbon is in our buildings. Broadly today, about 50% of it is in the materials and construction, and 50% of it in the operation of the building. And if you look at where that 50% in the materials is, one of the surprising findings is that around 20% of that comes from the fit out and the change of the building in use over time. Those are the blue spikes you see on that graph. So where's the carbon in our buildings? There's about 8% comes from steel, that's globally, and about half the steel we use in construction. Interestingly, about half of that steel is used in reinforcing bars in concrete. So if we were to update and modernise that technology, then we could change the carbon impacts quite considerably. Even the public now know that about 8% of our carbon emissions comes from cement. And when you look at the pathways to net zero, you see improvements in processes to 2030 and then a deep dive to 2050, which is based on carbon capture and storage, which we're now starting to see come online. And one of the projects I'm engaged in working with David Chipfield Architects in Berlin is the new Nobel Centre in Stockholm. And here we're using Heidelberg's carbon capture and storage cement from Brevik in Norway. But we must always remember that these are still having off-site consequences. This is the cement plant in Brevik, which has been there for, I think, about 100 years. But it has an impact on the landscape, and of course the carbon we capture has to go somewhere. So the industry, to some extent, has been defaulting towards timber as a solution. This is a building called East by the campus in London. Built very quickly, lightweight timber solution. A great project, but is timber the answer to a sustainable carbon question? I would suggest it isn't, based on the amount of supply of timber that we can actually get. Where we're working in places like this is Vancouver Art Gallery with demand in British Columbia, Vancouver. The industry there is well established, and they have a policy of first of all designing everything in timber before you choose other materials, a wood first policy. Now that's fine where you're working in a location where you do have a timber industry. But our studies on timber and the carbon in timber suggest that if we don't manage the resources properly, we're not recapturing the carbon once we cut down the trees. And if at the end of life we release that carbon back into the atmosphere, then we've actually created a worse situation in the carbon than if we use steel or concrete. So timber isn't the answer to all of our problems. And then when you look at the land use, the things we need to use our land for in terms of carbon capture through forests, in terms of land use for food and agriculture, and if we start to compete with those uses for the construction industry, then I think we'll run into some fairly significant problems fairly quickly. So we need a mix across all of our materials. When you look at the global demand for materials and the amount that's actually needed, and the amount that we can actually get from timber, 5 million cubic metres, it's relatively small. And then when we look forward to 2050, half the buildings that will exist in 2050 have not yet been built. So there's an enormous amount of building ahead of us. And that's not just in the building industry, but it's also in the infrastructure industry. We have a massive infrastructure gap, and we're seeing, even in Europe, we're seeing the impacts of climate change. The recent tragic flooding in Spain suggests that we're going to need to build infrastructure just for climate resilience. And then you look at urbanisation. You've got 4.2 billion people living in our cities, and that's happened relatively quickly in a fairly unplanned way. So Sao Paulo, for example, went from 2.5 million to 22.5 million in the space of about 50 years. And that massive urbanisation has led to 1.1 billion people living without inadequate housing. And if we're going to meet sustainable development goals, which are all about alleviating poverty, then we need to build the basic needs of people, housing, and all of the social infrastructure that goes with it, as well as the infrastructure that we need to deal with climate change. And then when we add another 3 billion people by 2050, we're talking about building 100,000 houses per day. You see other figures like we need to build a city the size of Paris every month. So when I look at some of the carbon reduction strategies, this one comes from Marek, so I feel I can speak to it. At the top you see build nothing, and I think that's a very European perspective when there's so much that we do need to build. And when you think about the amount we need to build in construction productivity, then you see productivity has been relatively flat in construction compared to, say, manufacturing. So we also need to speed up the way we build. So with all these challenges, what can we do? Well, one of the opportunities is modular construction. So off-site construction allows us to be much more particular about the materials we're using, as well as speeding up construction, eliminating waste in the process, and perhaps introducing more of the techniques like 3D printing and so on, plus other components that we would install into our buildings. This is Atlantic Yard, one of the biggest modular projects in the world, in Brooklyn in New York. 36 stories modular, all built in a factory, able to take a 4D process, sequence everything, put it together quickly, and deliver it on site as singular units that you then connect together. And I'm working at the moment with the Norman Foster Foundation in Madrid to develop a building system for a client in Portugal, DS2, which must address the problem of building quickly, building sustainably, and the affordable housing market. And we can build off-site. This is a project in London. It's the Cheese Grater with Richard Rogers, working with Lago Walk, a very innovative contractor, and 85% of this was built off-site. I would suggest we could go just one step further and have a plan to disassemble and change and adapt to this building over time, and then we're able to recover components from our buildings when they reach the end of life. So we can optimise our projects. This is China 2. It's a 538-metre tower in Beijing. It's designed using all of the techniques that we have available to us in terms of linking our software programs and making it parametric so that we can adjust and change the parameters and find optimal solutions to any particular problem. In this case, trying to maximise the available floor area for the minimum amount of materials. So we can cycle through thousands of variations and find the best solutions, so we actually minimise the materials we're using in the buildings. And then if we take that down to a component level, this is a study we made in our office in Amsterdam, looking at a standard component and how much we could save through 3D printing and parametric optimisation, 75% saving in materials. And we 3D printed a bridge in Amsterdam as a demonstration of how that can work. And then that's also entering the mainstream construction industry. This is a project called Korea Tower by Dijon and Gaia Architects. It's a competition that's won. The prototype you see in that picture, using precast concrete pieces that work together in compression, fulfilling the function of a, say, a 300mm flat slab in reinforced concrete, using only 100mm working in compression.